Hello everybody. In this video we are going to see some sample college entrance examinations for grade 12 on derivatives. Before we start seeing or solving the questions, let us see some rules of derivatives. Some of the rules of derivatives, constant function derivative, it's always 0, don't forget. And if it is linear, x derivative will be 1. And in general, x the power of n derivative will be it's going to be n times x the power of n minus 1. The exponent here will come as a coefficient, and the exponent will decrease by 1. That is x the power of n derivative. And the other one, at this point, you need to remember, like instead of x, it is f of x, the power of n derivative. If it is, it's going to be the same manner. The n will come as a coefficient, n times, then f of x, the power of n minus 1 times the inner function derivative according to chain rule also. Previously, we have seen the chain rule. And then the other one, if it is exponential function, a the power of x derivative, the outcome will be a the power of x itself, but times ln a. There must be. And this time e the power of x, it is special function. The derivative of e the power of x is e the power of x itself. Again, don't forget the chain rule. If it is e the power of ax, the whole derivative, the outcome will be the ax will be derivated. Then the x derivative will be a, so a times e the power of ax. Here nothing is changed, just as it is it goes. Okay, this one as it is it goes, but a is multiplying. And again, ln x derivative, don't forget, ln x derivative, it is 1 over x. And again, logarithm of x to the base a, derivative will be the same, 1 over x times ln a comes here. And when you come to trigonometric derivative, like sin x derivative will be cos x. And again, cos x derivative will be, don't forget, these are the main one. Cos x derivative is negative sin x. And finally, tan x derivative will be sec square x. Don't forget this rule. So constant function derivative always 0, and linear function like x derivative is 1. This time, if it is like ax, okay, this is also linear function, the derivative of x is 1, so 1 times a will be a. Don't forget that. So these are some rules, but not only this one. There are so many rules, but before you start derivatives, you need to remember at least this one as an introduction. In addition to the constant power rule and trigonometric rule, exponential rule, there are some rules, like previously also we said it, combination, when two functions are combined by plus or minus, that is some rule that is stated as you see. And difference rule and product rule, you don't have to forget the product rule, like f times g derivative. Previously we tried to see it, it is here, product rule. And f over g, that is quotient rule also here, as you see, it is stated. Finally, the chain rule also, don't forget. In case of chain rule, if there are two functions composed each other, f of g of x, the whole derivative will be f derivative of g of x, then times the inner derivative, the derivative of x. These are some of the rule that we need to remember before starting solving college entrance examination on derivative. So let us go now to the exercise. Okay, here it is. The first question, as you see, what does it say? It says the derivative f of x is equal to pi square. So we need to find f derivative of x. Common mistake, student, they will say 2 pi. The reason, there is exponent 2, and they will consider the pi as a number, as a variable x. But pi is not a number. Pi is approximately 3.14, but it's an irrational number. So the derivative of constant number is always 0. So this is wrong. This answer is wrong. So the derivative, it has to be the derivative of the function will be 0. So the answer is going to be found in D. That is the first question. The second one, it says f of x is equal to 6x over x plus a. So what is asked? We need to find f derivative at a is equal to 1. So we need to find a. The a value is asked, but this is given condition. F derivative at a is already given to you. Okay, so let's derive first. We need to apply quotient rule here. There are two functions, numerator and denominator. So f derivative of x will be according to the quotient rule, it's going to be 6x derivative times x plus a minus 6x times x plus a derivative, the whole over the denominator is x plus a the whole square. So when you do this, let's underline here. So f derivative of x will be therefore the derivative of x will be 6x derivative, it will be 6, just write it as it is, 6 in bracket x plus a, then minus just 6x only, because x plus a derivative, constant derivative is 0 and x derivative is 1 here. So the bracket 1, only 1 left. 1 times 6x will be 6x remain. So in the denominator, what do we have? X plus a the whole square left. Then at this point, we can substitute f derivative at a. F derivative at a means when you insert a here, a plus a will be 2a. Then 2a times 6 will be 12a. Minus again there, it will be 6a. We substituted. The whole over, again, a plus a will be 2a. The whole square, which is equal to 1. We do have this one. Okay, let us go to the next page. So we stopped, okay, we stopped at 12a minus 6a, the whole over 2a, the whole square is equal to 1. We stop here. So the difference will be 6a. 6a is equal to, this is 4a squared. By crisscross, it is going to be 4a squared. So we can divide by a both sides. A must be different from 0 actually. There is no a in the choice. So 6 is equal to 4a. Then divide by 4 both sides. So the value of a is going to be 3 over 2. So you can go back and see the answer. The answer is found in C. But even if it's longer process, I'm trying to show you the formal way. You can use shortcut, but this one is the formal way, how to apply derivative, because at the same time, this one is lesson. Okay, the next one. Again, here, what is given? G of x is given. G of x is equal to, it says, G of x is equal to f of x over x plus 1 plus f of x the whole square, it says. F of x the whole square. Okay, let's do it. F of x square. This is given to you. And then what is asked? We have f of 1, we have the value, which is 8. And f derivative of 1 also, it's given to us, which is 2. And then we are asked to find g derivative at 1. Okay, this is asked. This is asked one. Therefore, we need to derive first g. G derivative will be here quotient function. When you derive this, the left hand, we have to derive the right hand. The whole thing has to be derived. So when you derive this one, it is quotient function. I need to apply that one. So f derivative of x times x plus 1, then minus f of x times, the denominator x plus 1 derivative is just 1. So I can skip it. What left? X plus 1, the whole square, plus, now the square of the function derivative will be 2 will come here, and f of x times f derivative of x by chain rule. First, we derive the exponent, 2 comes here at the coefficient, and then the exponent decrease and f of x remain, then times the inner derivative. Therefore, let us substitute now. G derivative at 1 means when you substitute 1 in every x place, this is going to be f derivative at 1 times 2, because 1 plus 1 here, and minus f of 1, the whole over. Again, 1 plus 1 will be 2. The whole square will be 4. Don't forget here. Plus 2 times f of 1 times f derivative 1. Then let us substitute everything. In place of f derivative of 1, we can substitute 2. 2 times 2 will be 4. Minus, then f of 1 is 8 over 4. then plus 2 times f of 1 is just 8 times 2. So when you finalize this one, by the way, this is going to be negative 1 and this is going to be 32. So negative 1 plus 32 will be just 31. So when you see it, it looks confusing, it looks long process, but truly speaking, I don't think, but you need to apply a step-by-step process. So it's all about the rule. So the answer is going to be B. The next question here, what is given f of x is equal to, let's write it, x e the power of 3x minus cosine of 2x. This is given to us. And then we are asked, we need to find f second derivative at 0. First, we need to derivate this one twice. So first, let's find f derivative of x. F derivative of x, here we need to apply product rule because two functions combined by times, x and e the power of x. So product rule, the first derivative times the second one as it is, plus the first one as it is times the second e the power of 3x derivative. You see, I apply here product rule. Minus cosine derivative is, negative sign, so plus sine of what? 2x as it is, but times by chain rule the 2x derivative, which is 2. So let us get it. F derivative of x, this is 1. So simply e the power of 3x plus this derivative, the 3 will come as a coefficient, so 3x e the power of 3x. You need to take care with what I did. E the power of 3x derivative is itself, but times the 3x derivative will be 3 there. So that 3 comes as a coefficient here. Plus 2 times sine of 2x. This is the derivative of the first derivative of the given function. Let us continue. Second derivative. Second derivative, when you say, we need to derivate again, the same. This derivative will be 3 e the power of 3x. And here we need to apply product rule. So first we need to derive 3x. 3x derivative is 3 times this one will be 3 e the power of 3x plus again this derivative. This derivative is itself, but the 3 will come here together. So it's going to be 9x e the power of 3x. You need to save time when you are doing it. You don't have to write each and every thing there. Then plus the sine derivative, cosine. But 2x derivative will 2 comes and will be multiplied with the coefficient here. So it's going to be 4 cosine of 2x. Then what is asked? This is f second derivative. So f second derivative at 0 means we are going to substitute 0 everywhere. So when you substitute 0, this is going to be 1. So 3 plus this also 1, because any number the power of 0 is 1. E the power of 3 times 0 means it's just e the power of 0, which is 1. 1 times 3, 3. Here also it will be 3. But this is going to be 0, the whole, because there is x here. When you substitute 0 here, 0 times anything will be 0. And at last, cosine of 0, because when you substitute 0, cosine 0 is just 1. So 1 times 4 will be 4 left. So when you add, the answer is going to be 10. So this is the derivative of the given function at 0. So these are some sample questions. I will continue solving derivatives, integrals, and additional exercise, especially for college entrance examinations. It will be helpful, so follow me. But I need to give some individual practice for my followers. My followers are my students here. So please try to do this exercise. What you see here are 2 questions on derivatives, like the same way I applied. And when you are done, you can send your answer by the email address that you see at the end here. It is brhaniubishat@gmail.com will be my Gmail address. Send your answer and then we can communicate. So the teaching learning process will be two-side. It will have two-side flow. So thank you for watching. Don't forget to subscribe and stay tuned. More videos are coming. Thank you.